Your subscribe keeps us motivated. Subscribe now.
Body A of mass 4m moving with speed u collides with another body B of mass 2m at rest. Okay, fine. So let's draw it. So let's say that this is our body A over here, and here the mass is 4m, right? Is moving with the speed u. Okay, so speed here is u in this direction, is collides with another body of mass of body B of mass 2m. So let's say this is our body B of mass 2m over here, and initial velocity here is 0 because it is at rest. The collision is head-on and elastic in nature. So head-on collision and elastic in nature. After the collision, the fraction of energy lost will be how much? That we have to calculate. Okay, so we have to calculate the fraction. So let's see now. First of all, fraction will be how much? Let's write here. Fraction of energy lost, fraction of energy lost of the colliding body, and that will be equals to how much? Energy, you can say energy lost, no? So that will be fraction we have to find. So energy lost whole divided by how much is the initial energy, that is fraction. Fraction means how much energy lost upon initial energy of the particle. Which body? Body A. So we have to focus on body A. So we can say, see, energy is losing. Okay, which particle is losing? Body A is losing our energy. So energy is lost by it. So final energy will be less than the initial energy, right? So kinetic energy initial minus kinetic energy final, because they are moving. So we are dealing with kinetic energies, whole divided by the initial kinetic energy. That will be our fraction, right? And what will be our final kinetic energy and initial kinetic energy? Our initial kinetic energy will be half. What is the mass of body A? 4m u square, because u is the initial velocity, correct? Let's say after colliding, the body A is moving with any velocity v here. Mass will still remain 4m, correct? So minus half 4m into v square, v1 square, or let's call it as v1, because v2 will be the velocity of the second particle, v1 square whole divided by half 4m into u square, right? Now let's take half and 4m common on the numerator and denominator. What we left with here? We left with the u square minus v1 square whole divided by u square. This is our equation number 1, correct? This is our fraction, and we have to first figure out the value of v1 and then substitute here, and we will get our fraction, right? So let's write the condition for elastic collision. For elastic collision, the final velocity of the particle will be, this is our formula, we have to remember this, this is from the derivation of elastic collision, m1 minus m2 upon m1 plus m2 into u1 plus 2m2 u2 whole divided by m1 plus m2. Now in this is general case. In this particular case, our initial velocity of the second particle is how much? 0. So second particle will have, this part will be how much? 0. So we will get our v1 as m1. m1 is how much? 4m. m2 is 2m whole divided by 4m plus 2m into u plus 0, correct? Now this will be giving us 2m upon 6m into u, and that will be giving us, m and m cancel, 2 by 6 is u by 3. So u by 3 is our final velocity of the first particle. We just need the final velocity of the first particle. We don't require it for the second particle, because the question says fraction of energy lost by the first particle A, right? So let's substitute it in equation number 1. It will be u square minus, so our fraction, okay, will be, lost fraction will be how much? It will be, let's see, u square minus v1 square, u square minus v1 square. v1 is u by 3 whole square whole divided by u square. So that will be equals to u square minus u square by 9 whole divided by u square. So that will be 8 by 9, okay, and u square will get cancelled with u square. So we left with 8 by 9. So correct answer is option B.